Right in June 2021, right? So it's a period of the wrong thing. And June 2021. The period why it is up. All right, so take a look here. Figure 6 shows a simple DC motor, which consists of a coil of wire. You all seen it? Coil of wire. ABC between the poles of the magnet. The dotted line represents an axle about which the coil can turn. The current flows through the coil in the direction shown. So it's good to go, right? You don't have the other parts of it, but you don't need it, right? Draw the magnetic field between the poles and then put the direction of the force on D. Right? So draw the direction of the magnetic fields. That is two marks for that. And state the direction in which DA will move. Go ahead. Do your thing. For the magnetic field and for the direction that DA will move, right? What the law we using there again? Which one? To find the direction of the force. Left hand rule. Right? Left hand rule is also Pauli motor rule, right? Go ahead. Try it quick and I'll correct the board and out. Ready? Take your time, take your time. You can do your thing. Draw your magnetic field first and then draw the force. We're not in a rush, take all the time. But we'll take forever.
So that was really respectful. It's so open space. Okay.
So it was small, but not big.
It's like you listen on that.
All right. Right, class almost done, so I'll do it now, right? Right. Oh, the problem is I can't write with my pen. Oh, this. All right, so magnetic fields go from where to where? Magnetic fields move from north to south. It wouldn't actually look like this, huh? Right? But for this question is like that. But remember, when you have current going, the fields, remember, I gave you a diagram where the fields build up from one side and push it downwards. So it wouldn't really look like that in real life, right? But what they want is this, right? Next, apply Fleming's left-hand rule to which side? Which side? DA? Yeah? Yeah? So left-hand rule, for those who online, you can look at the camera. So magnetic field going north to south, current going D to A. So the force outward. Right? Current going D to A, magnetic field north to south. So I am getting an upward force at DA. And obviously a downward force at BC. How will it turn? Clockwise or anti-clockwise? It's going up and down. So it's turning like that. Huh? That's clockwise here. That's how clock will go, right? A wise clock. Are you okay with that? So it's going up at DA and going down at BC. You okay with that? Up at DA, down at BC, so it will turn clockwise, right? And those things say diagram. Pretty important. Because that'll be common sense. And then you'll put it in words. Right? You can put it in words. So what would happen if I move now? If I take this off and I move, what I stay, I really. Right. How do I get all them people? I'll double everything there on the other muscle and we can share. That'll stop you the mind body. When I can't write. All right, nice. So, I mean, that is still. All right, let's go again. Let's go again. Next part, let's clear this. Online, are you okay so far? So just clear it up. Nice. Right, city direction and DA will start right. Good. Name the rule, part 3. Write down the rule. What's the name of the rule? That makes that down. Very good. Then I get it. That's 4 marks. So 2 marks in the direction of the magnetic field and 1 mark for applying. That really help all y'all to see actually. 2 marks for a magnetic field. Be ready, the rest of them will be ready. Yeah, be ready. Right, name the rule, Fleming's left-hand rule. You can put it in brackets. Don't put that, right? Don't put the commercial rule. Explain why the split ring is used. Well, what is the purpose of the split ring? Huh? I'm looking for the exact answer. You have the right idea. What's the purpose of the slip ring? Sorry, split ring. I gave it to you in the explanation. Right, so the split ring allows, right? The split ring allows for the coil to continuously, write it down. The split ring is used so that the coil will continuously rotate in the same direction. So that the coil will continuously rotate in the same direction. Right? So it allows for the same forces to be exerted as well, right? When I use the load. All right, nice. That's part 4. Part B now. This is the graph of an AC generator. Right, I'll have to zoom out a little bit, right? Find the frequency. Okay, I'll zoom out. I just find frequency earlier. I just find frequency. Yeah, remember this from waves and things. How do you find frequency? Frequency is equal to what? 1 over yeah. How do we find frequency? 1 over the period. Very good. Frequency is 1 over period. So you have to look at that diagram and see what the period is. Right? So we're doing frequency is 1 over period. Look at the diagram. How much is period is just? Period is time for 1 complete cycle. Right? So time it takes to do that. Sorry. It's just 1 period here. 0 point? Sure. 0.2, right? It has to go here and come here, come back here, right? How much is that? 1 over 0.02. What's the SI unit, David? For frequency. Okay, sure. Anybody? Well, Nuria said. Nuria said. Right? Since we on this, let's just talk through a few things. Right? Because you would have had to remember this when we did electricity. Right. Look at the graph. What is the peak value of the graph? The peak value is the highest value, right? So the peak value is 200. Okay? I don't know if you all remember this. What is the peak to peak value? Peak to peak value is what? Peak to peak value is 200 minus 200, which is 400. That's okay? Peak to peak is largest minus the smallest. Okay? And your amplitude is 200, or your largest value is 200. right? That is called your peak value. That's peak value, right? Let's go again. That is your peak value, right? What you have to after calculate the frequency. Oh, what you say? Shift it around. Nice. The peak value is applied by the generator. Calculate the peak value current. All right, so back the peak value of voltage here, right? Was 200, right? So you see, in a magnet question, you have to know electricity. That's why next week I'm testing on both of them, right? For those who knew, go back and watch electricity videos. You're on the LMS, go to electricity and watch the 3 videos, right? 3 or 4. They're not edited, so you will have to just speak through when I'm not talking, right? Right, find the value current. What's the formula for current, Rima? I is equal to what? Very, very close. Yeah. Or less, yeah. No, that's it. Okay. Yes, I is equal to V over R. Not V by R. V over R. I is equal to V over R. I will get out fast and how much you get. See how easy, right? You have your voltage here, current here. I mean, resistance here. All right. So the answer you got is what? 200 divided by 100, which is 2 what? What's the SI unit? Amperes. 2 amperes. Nice. Copy it down. Let's go again. Let's go again. Taking it off, right? Right. What do we have now? The generator is subsequently rotated at twice the frequency. What will that be in period? Right? Right your answer. Again, I give it a hint. Right, the generator is subsequently rotated at twice the frequency. State the effect on the period. Formula right there. So look at the formula and see what will happen if it double frequency, what it does to period. Right? Look at the answer. So if we double the frequency, it now becomes 2n. So period is what? Can I factor out a half there? So if you look at this, both of them are the same. So whenever you double the frequency, the period is half. That's too much, right? So let's write it in half, right? Half period. Okay? If it's double frequency, a half period. And last part is I'm just going down, right? What happens to the value of the output voltage? Picture? 1 mark. Stay the same? What will happen? What will happen to the value of the, sorry. I that's say what? It will increase, it can be exact. So if you double the frequency, right? If it double the frequency, it down. Okay. Yeah, if it double the frequency, would the coil be moving faster? They're moving the coil faster? Right? No, yes, no. What y'all think? And if they move the coil faster by Faraday's law, what will happen? It should generate a larger voltage. Okay? So if it's going twice as fast, then the voltage should be double. That's great. Right? So the output voltage should be double. Whose law is that? Faraday's law. Alright, nice.
Well, if you practice in the meantime, practicing it. Well, practicing it.
Alright. Next one. So let's see how is play this again. Nice. Huh? Give it. Right? Yeah, that's the end of that. So right, what do I get next one? I'll go back again. You want to move this way? You're okay with that? So our question will look something like that, right? Everybody okay with that last one there? Yeah. Let's do our next one. Okay, go again the next year here, buddy. And I just go back, I'll go back and I'll tell you, see. Okay, this is why I done with it. I want to make sure that I get a full screen. All right, so that was, what year was that? 2021. There was a next one in oh wait, you do have 2021 was the most recent year. All right. This one is You can't do this because it's a graph, or should I make it a graph still? Alright, here's what. Just label it up for now. Draw a diagram and label it. What year is that? 2018. We look at it just now. Right? So just label X, Y, and Z. I think it's June 28th. Actually, you could just write the book and then more. Right? Just write the year and write X, Y, Z.
Oh, okay. Yes.
Write the year and write X, Y, Z.
Yes.
June 28th.
What time?
Or 9. 28th. Start with 9. Number 1. Right? Ready? All you're doing is just label it X, Y, and Z. The rest is a graph, but we don't have. The rest is graph paper, I think, and I'm gonna make all it good now. Okay, nice. X is what? X is your. What you all think? Primary supply, right? That's your primary supply. C is your what? C is your Z. C is your what's our name for that? The soft iron core, right? C is your soft iron core, and Y is your secondary what? Coils, right? Secondary coil. So Y is your X is your primary supply. X is your primary supply. C is your soft iron core. And Y is your coils. But secondary coil. Yeah, you gotta be exact, right? Y is your secondary coils. Right? Secondary coils. I just want to talk you through because you all know that stuff, right? But look at the graph. The graph is primary voltage versus, and let's zoom in a little more, right? The graph is primary versus secondary, right? Plot a graph of BS versus BP and then find gradient, right? But my question is, what does the gradient represent? How am I going to find NS? So I'm going back here. What does the gradient represent? Remember, you're plotting a graph. Here is BS, and here is BP. What does the gradient give you? Very good. The gradient gives you BS over BP. So technically, you have the ratio. That's okay? But okay with that? Yeah. So my question again is, if I gave you a value for NS, let's say it's 100, how do you find NP? What are you gonna do? Multiply type, right? So you're gonna use formula. What are you gonna use? BS and BP is NS over NP. We have it the other way around, but it don't matter, right? Once the BS and the NS in line, right? So if you know this, then you can easily find this. That's okay? But what I want you to remember, always remember your gradient is your quantity on the y divided by your quantity on the x. Okay? That is your gradient. All right, please make a note of that, please. Right, make a note that the gradient is always the quantity on the y, especially those who put on the labs not a little while. Quantity on the y divided by the quantity on the x. Right, always remember that anytime you plot a graph, that gradient is whatever on your y, whatever on your x. And of course, it's up to you to remember those things, right? Remember what the actual formula represents. All right, let's go again. All right, so I want to do that, right? Let's try next year. Here's the problem. We'll have it for this. Right, remember after next class, I'm going to start to revise. I'll start to revise the thermal, right? And then we do mechanics of them. Wait, yeah, talk in there, forget 2 hours. Right. All right, let's go again. This is for those who writing down the year, Jan 2018. Jan 2018, we're going all the way to number 6. Let's go. 2018, sorry, take a little read. 2018, number 6. Do I zoom out, boy? Yeah, I'm gonna zoom out a little bit, right? Actually, you don't need to touch it. 2018, number 6. Take a little read. I'm moving up just now. No, you gotta show us. Figure 6 shows a magnetic field between the poles, right? Complete the following diagram to show the magnetic field around a conductor. Do that. Go write the question, just draw the X and put the magnetic field around it. Whose law is that? What the law are you using there? Right hand grip rule, right? Go ahead. Ready? Right, so X means what? X means in or out? In, and yeah, so that would be what, clockwise? Yeah. So you will draw it like this. I'm gonna get a little drawings here. Clockwise, right? Supposed to be circles, right? Mine could be a circle if I close up here. Right? Circles. How much marks are that? Yes. That was 2 marks. Easy 2 marks. Next one. The resulting magnetic field. Right? Draw the resulting magnetic field when the current carrying conductor is placed between the plates. Do you think here now? Look up here now. Pardon me? What's the question? Draw the magnetic field. Right? We put a current carrying conductor in the magnetic field. Whose law are you using? Fleming's left-hand rule. I told you all to write a little summary. Anyway, I'll give you a summary.
How you know when it feels the love?
Right? So you have to use left-hand rule to help you. You can't just magically draw the P lines. Right? Oh yeah. Right? So use the left-hand rule. Current going in, right? And after you figure out where the force is, you gotta know where the P lines are, where the majority of P lines. Right? We did one like this last week. Well, last time. And ready? Right? So left-hand rule, right? So the magnetic field going, sorry, the currents going in, magnetic field going north to south. So my first finger going north to south. So the forces down, right? So if the force is down, which was a little detail, the P lines will look like this. Wait. Plug in. So. Understand. Bobby. Right? Right, so you put your little arrows here and you put more P lines on top, less underneath. What does that mean? It will push the conductor downwards. Okay, let's go again. Or in the next part, ideally, I don't want you to look back. I want you to see what you remember and write your own explanation. Okay, the next part, right? I see you looking back, you come on the board and you write all the steps and then do a graph one, right? All right. Out looking back, please try this. Everybody writing? Everybody writing? Let's go again. Next part is the what is CRT? That's in motor, right?
Yes.
That's a better looking diagram, right? But that's in motor. You've seen everything? Seen the what's called this again? Slip rings, you have a coil, your magnet, everything, right? What is X? X is the right up, X is your split rings. One mark. Tell me. It's the one for the motor. So it's the split. It's a motor. Right? Look at it, the motor split. Look at it there, it's split. Is it a whole ring? No, it's a half, right? So it's a split ring. All right, so therefore, right? Let's go again. Yeah. Let's go again. Right. Explain what happens to all. This is the perfect. This is where I got these steps from, right? Explain what happens to the motor and include in your answer all those things. Please don't look back. Try and do it without looking back. They give you what you want. They give you what you want and they give you the order. Right? Try it, please. Explain what happens when the switch is closed. Right? Your answer should include all of that. So, from a diagram, right? A here, B here, C there, and D there, magnetic field, note this out. Explain what happens. Okay? Explain what happens. Right? And give them all those things. Go ahead. 5 minutes or 5 months. 9 marks, sorry. 9 marks for that. Easy 9 marks. So without looking back, try to see if you can write all this stuff. Right? That's the equation I go to. So tell them what direction current moving in. Well, I'm gonna go back to the diagram. Put up. What direction current moving in? Let's go back to the diagram. Current going from eta was sorry. Here's positive, right? So current going theta, theta, beta, E. Yeah, put it now what I yeah, do it out. Current going theta, theta, beta, E. But I have that, make a little diagram here one. Quick. Right? What the force being applied? What direction the force moving in? Focus on AB. What direction is the force on AB? Up or down? You can use anyone. Anyone you can use. What direction is the force on AB? Right? So the first thing is telling them the current going D to C to B to A. All right? Then use the left hand rule and figure out the direction of the force. What's the force on DC and what's the force on AB? What's the force on DC and what's the force on AB? Right? What you all got? DC is what? Down. Right? Magnetic field north to south, current going D to C, so your thumb going down, right? So DC is down, AB is up. How will it turn? How will it turn? Right? So here is down, and here is up. And here is up. Yeah. How much one? 5 6 centimeters. Yeah. All right. What the next thing after that? Actually, again, it. Sure. Sure. Huh? What the question? Oh, sorry, what else? Go ahead. Write everything. Okay. Go ahead. So we work out the force and we saw it moving clockwise. That's okay. The force applied, or sorry, what the rule they use? Fleming's left-hand rule. So tell them that you use Fleming's left-hand rule to find the direction of the force. Easy, right, Anya? The direction of rotation, Anya. How it moving, Anya? Clockwise. Easy marks, there's 9 marks, all of the they have 6 already. How is continuous rotation achieved? You have to tell them 2 things. When the coil is vertical, what's happened? Inertia pulls it to the opposite side, right? So it doesn't stay stationary. And then, what's the part of the motor that allows it to turn continuously? Split ring, right? So because of the split rings, it allows it to turn continuously since it experiences the same force on the left side and the same force on the right side. And you're good to go, 9 marks. Right, I'll stop today. If you do 2 laps, a little break, and then we start the first lap. All right. So after that, we'll stop. Next week, we're going to do electricity, more magnets. Right, I'll try to give you a long something. That's not all of you all on the elements, right? Everybody should have access to the elements except for the calling names. Peon, you didn't submit yours. Cedar, you didn't submit yours. Rihanna, you didn't submit yours. David, you didn't submit yours. You didn't tell you before. On the group chat. Dante, Elon didn't do his own. Raj didn't do his own. Chelsea and Rihanna. Huh? So, say no problem. I said, I'm going to get no again. Right? So, do fill it out. All right. All right, online. You have to stop there.